With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Let's start the question. The question says that which of the following statements is incorrect? So in this question particularly, there are four options in the form of statements being provided to us, and we have to look for the incorrect statement as in the incorrect option. So let us have a look at the solution to our problem in this case. If we try to consider each of the statements one by one, let us first start from option first, that is the very first statement which is given to us. First option says that in solution of volatile liquid, partial pressure of any component is directly proportional to its mole fraction in the solution. Basically, what happens is, if we take into consideration the Raoult's law of partial vapor pressure, Raoult's law. According to Raoult's law, how the statement goes is that for a solution which is containing a volatile component, if we take into consideration the Raoult's law, it says that according to this law, for a solution which is containing volatile component, the partial vapor pressure, that is P, the partial vapor pressure of each component is directly proportional. This is the proportionality sign. It is directly proportional to the mole fraction of each component, in the solution. And how does we represent the mole fraction according to Raoult's law? The statement, as per the statement, the expression goes as the partial vapor pressure is directly proportional to the mole fraction. This is represented by a symbol chi. Okay, here X, this represents chi. So this is the mole fraction and this is the partial vapor pressure. Now what happens is, if we remove this proportionality sign, we get a proportionality constant, which in this case is denoted by P equal to P naught chi. This is the statement expression for Raoult's law of partial vapor pressure. Now what happens is, if I try to make this particular expression more informative, let me specify what are these terms all about. Here chi, as I already mentioned, it represents the mole fraction of component. Chi stands for the mole fraction of the component. Here P naught represents the vapor pressure. Vp means vapor pressure of pure component. Vapor pressure of pure component. That's what P naught stands for. And P, as we already mentioned, that P here denotes, P stands for the partial vapor pressure. Vp stands for vapor pressure of component in the solution. So this statement, that is option number 1, is correct. Option 1 is correct. This statement is correct. Now let us have a look at option number 2 as in the second statement. This was all about option A. If we take into consideration the statement B goes as, in a closed container in equilibrium of two volatile liquids and their vapor, mole fraction of more volatile component is higher in vapor phase. See, what happens is basically the component which is more volatile. Now, what is volatility all about? Volatility means the tendency of a compound to form vapors, to get converted into vapors easily. So what happens is, as the volatility or the volatile nature of the compound increases, more the component is volatile, it will be forming more vapors. So as the volatile nature of the compound increases, it implies that it becomes easy for the component, it becomes quite easily for the component to get evaporate. It can evaporate easily. And if a compound can evaporate easily, so in vapor phase, it will be having more mole fraction. Why? Because mole fraction is just a concentration term. So it can easily evaporate in vapor phase and it has more mole fraction. The mole fraction will increase in this case. Mole fraction is nothing but it just represents the concentration. Mole fraction represents the concentration of a component. So this statement, that is option number B, is also correct. And in this question, we have to look for the incorrect statement. So option C, we'll look forward to it, option C, and option B is correct in this case. Moving on to the next option, that is option C, it goes as total vapor pressure of solution of binary volatile liquid. Binary means there are two volatile liquids being present in a solution, decreases on increasing mole fraction of any component. So how we can explain this statement? What is the logic behind this statement? See, what happens is, if we are talking of the partial pressure of a solution which is containing binary solution in this case, so the partial pressure of the solution is equal to the partial pressure of component A plus the partial pressure of component B. Why here we are taking two components? Because it is clearly specified in the statement provided that the volatile liquids are binary. Binary means they have two volatile liquids present. So the partial pressure, the total partial pressure of the solution will be equal to PA plus PB, that is the sum of the partial pressure of two components. This we are writing for binary liquids, because here two volatile liquids are given to us. Now, if we further expand this by applying Raoult's law, so PA will be equal to P naught A multiplied by chi A. And similarly, we can write for PB by applying the Raoult's law. PB will be equal to P naught B multiplied by chi B. That is the vapor pressure of pure component multiplied by the mole fraction of it. So this is how we can expand this. So from this expression also, it can be clearly inferred that if, let's suppose, if the mole fraction of a component is increased, if it is increased, then the total pressure of the solution, the total partial pressure of the solution will also be increasing. Why? Because it is directly proportional as per the Raoult's law. But in the statement provided, what they are saying that the total vapor pressure will basically decrease. So this is completely wrong. So this statement is wrong. Why? Because if the mole fraction is increased, then the vapor pressure, that is the partial vapor pressure of the solution, will also increase. So this statement is incorrect. This option 3, the statement being provided in option 3 is incorrect. consideration the last option, or we can say the last statement which is given. Let us read it first. Option 4 goes as, Rawls' law is a special case of Henry's law in which the value of KH and P0 are identical. Let us see how we can explain this. What is the concept behind? See, what is the expression in terms of Rawls' law? If we go as per Rawls' law, the expression as per Rawls' law for partial vapor pressure can be written as PA is equal to P0A chi A. That is the vapor pressure of the pure component multiplied by the mole fraction. This is the expression as per Rawls' law. Let me number this equation as 1. Similarly, if we go as per the Henry's law, the expression as per Henry's law is P, that is the partial vapor pressure, is equal to KH multiplied by the mole fraction, where KH here is nothing but your Henry's constant. Henry's constant is what KH stands for. Then, if you try to observe this expression of Henry's law carefully, let me number this as 2. Here, this Rawls' law expression and Henry's law expression are quite similar. Why? Because this P term and mole fraction term is common in 1 and 2 statements respectively. So, what happens is, if P0A becomes equal to chi H, if P0A becomes equal to KH, that is the Henry's constant, then Rawls' law becomes, in this case, what happens is, Rawls' law becomes the special case, Rawls' law becomes special case of Henry's law. It becomes a special case of Henry's law. So this is how these two expressions are linked to each other, and hence what we can conclude about this statement is that this statement is also true. It stands true, it stands correct, right? So our final answer to the question being asked is that our final answer is that option C is the incorrect statement. Third option, that is option 3, is incorrect in this particular case. So this was all about this question. Thank you everyone.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.